All right. Tap, tap, tap. Is this thing on? Hey, there we are. Excellent. Okay, so we had a few votes on the Twitch poll leading up to this session for immutable objects in C Sharp. We also have one vote for deep dive into threading and asynchrony, which is also an awesome topic, but with just one vote, and I'm sure that's going to be a more interesting topic in general to people. I'm going to hold off on that, and we'll drill into immutable objects today. So let's start by just an introduction to immutable objects. Let's create, let's say a test project, .NET Core test project. Let's see, immutable object tests. We'll go with that. Could also create a console app, but uh, tests will allow us to do a whole bunch of different interesting things. It's my favorite mode for just trying things out when I don't actually need a console. So let's turn on live unit testing because that's just awesome when it works. And for a test as simple as this, it ought to work. I'm going to edit this though, and just for fun, I'm going to target net 472, although .NET Core is awesome as well. Let's come back over here to live unit testing. Let's see if this works. Looks good. Let's take out the target framework and just leave. In fact, let's take out the class too. That doesn't matter either. Oh, I can't do that? Have to group by something. Interesting. Okay. Don't need the namespace either. Per X units preferred style. Okay, so we'll put this up here for now, or down here for now, and up here. Let's create a new class for our first immutable class. We'll call it, let's say, file system entry. We're going to model a file system because that's a hierarchy and that's interesting. No, let's not do that yet. Let's actually do something simpler. Let's call it a tree. Okay? So we have our, oh, let's see, who just joined us? Can I tell who just joined us? No, I can't. Well, thanks for joining. Feel free to chat, ask questions, help steer the conversation. I thought I could tell. Last time I did this, I could tell. This is only my second Twitch stream, so I'm still learning the ropes here. Um, okay, so we have our immutable tree here. It's immutable by definition because there are no fields, so you can't mutate it, right? That's not that interesting, however. So let's give it our first field. Every tree has fruit, a height, maybe a kind, the type of tree, right? So a type of tree. Now we want it to be, obviously we want to expose that, so string type. There we go. That's roughly immutable. I can go over here and I can say new tree, and I can retrieve the type, but I can't actually change it. So in fact, let's do this. Public unit test one, I test output helper, logger. So now we can even print it out. Tree type. There we go. Oh, live unit testing died. Let's get that started again. Okay. Oh, we got an argument null exception. Wow. Such a simple program. We've already blown it. Let's see what happened there. Oh, I think it actually was thrown from this method here. unfortunately, the live unit testing doesn't give much by way of call stacks. So if we switch to Test Explorer, we can verify this. And yes. So logger is not going to be null, argument null exception. So it doesn't like that we passed in a null value. So that actually leads us pretty well in, though. We need to set type, but type is immutable. That was kind of the whole point, right? So we need on this immutable type to actually make it more interesting. Let's do a whole bunch of different frames here. To make this tree type more interesting, we don't want to make it mutable because it's an immutable tree. That's the whole point, right? But we need to provide a way to set this value. So one basic way would be to say, let's just create a constructor where you can set the type, right? Done. And a tree with no type, it doesn't make sense. So let's add a input validation there. Make this a little bit wider. In fact, I might as well just fill the whole screen, right? Well, no, because then you can't see the test window so well. I'll put this over here. Is that better for you? I trust that nobody's chatting right now because I don't see anything. Hopefully it's working. Either one of you who are watching at the moment, feel free to throw something in the chat window as validation that it works. So we're going to call this an apple tree. Let's see what that does for the live unit test. Okay, we're passing now. Yay. And I can look at the output and we can see, oh, look, indeed, we did print that this was an apple. So that's great. Now we need a few other type. Now, first of all, I feel bad about this field being mutable. On my immutable types, I tend to actually force them to be immutable. Now we could also use an auto property with a getter only. So sure, well let's do that. There. Now, if I said private set here, then that actually means that it is mutable within the class itself, which I don't want. So this getter only means it actually is a immutable property. So let's do another one. Let's call it fruit count. Okay. Now again, I'm going to get rid of this private setter. And then of course I need to go up here and say fruit count, initialize the property, we're done. But I just made a breaking change. This is one of the downsides to immutable objects, the way we're defining them, is every time you add a property, it's a breaking change. So we'll talk about that in a bit too. This apple tree has 15 fruit on it. And so we'll print that out too. Wait for that to resolve there. Oh, I can't print a string, an integer though. So count, fruit count, there. Come back over here. Look at that. It's an apple tree with 15 fruit. Awesome. Again, not that interesting. Probably nothing new at this point. So let's do something more interesting. Let's say this class has 15 properties on it. Oh, let's see. Dot Morton says, wouldn't it be a breaking change if you had wouldn't be a breaking change if you had a default value instead? That'd be ugly if you expect it to be set. Yes. Oh, yeah. You could. Let's go ahead and do that. Let's say I shipped a tree once without fruit count. So I just create another overload of the constructor to add fruit count. That's actually a good lead-in for what we're going to do and automate later. So now I could say the old code would continue to work. If I go over here, fruit count is 0 because I never set any. In fact, that's a good lead-in. Thanks, Morton. Because now what we want to do is mutate the immutable object. Okay, so it's almost a contradiction in terms, but what we want to do is make it convenient because these trees will grow, right? They will spawn more fruit. And how do we make that easy? Well, we could do it manually today by saying tree v2, tree prime, is a new tree with the original tree's type and the original tree's fruit count, and then we add one. Okay? And then we're going to print that out again. We're going to say this is logger right line, second, or grown tree. And I hope you're thinking, well, that looks tedious. Okay, live unit testing died again. Let's get that back going again. Mutate the immutable? Scream? Yes, you should scream. What we want to do is mutate by copying. And if you've ever used the immutable collections, which I actually wrote originally for .NET, you'll understand by mutating the immutable, it's copy on change basically. So here we go. We've made a mistake already, right? Because fruit count 0, fruit count 0. Why? Because we are printing the immutable object. So we created a tree prime, but then we kept using the original tree. So now let's change that to tree prime and take a look at what we've got. There we go. It's still an apple tree, but the fruit, there's one more fruit. Yay. Now, we didn't actually cover some benefits, like why would you want to use immutable objects? Um, Modeling so many bugs in code. There's actually been studies, and I can't reference them off the top of my head, but there have been a lot of studies. A lot of bugs are because objects mutate. And that either because you're holding something you don't expect it to change, or maybe it is allowed to change, but you're not expecting it to change at that moment, especially when you're doing multi-threading, like concurrent programming or async coding. The problem space just multiplies if you've got mutable objects that you're manipulating, because if you're in an async method, while you're in an await, for example, suddenly the main thread is available for somebody else to go change something, and it changes what you think you're operating on. And when you come back and you start operating again, you throw an exception because, hey, the object just changed and you hadn't expected that. Locks. Yeah, you can protect things with locks for multi-threaded programming, but then you've got deadlocks to worry about. There's still reentrancy that can go in and mutate your objects. It's beautiful to program with immutable objects. And immutable collections exist, yes, but if immutable collections still store mutable objects, it only protects you so much. So having an immutable object graph, which is a term you'll hear me say a lot, so that the objects themselves are immutable as well as the collections that hold them, then you're totally protected. And the only thing you have to worry about is making sure you update your locals when you expect an update, like we just did here. So Dot Morton says, my manager is make things read-only until you can't. Keep it private until you must make it internal, until you must make it protected, until you at the very end must make it public, and keep it sealed until you must unseal. I love it, except for the sealed part. It's fine if you want to seal. I guess that's the safe approach to go. I don't tend to seal my classes. I tend to assume that people might override them. But if they're internal, there's no reason to seal, right? But I see a lot of internal classes that are sealed, and I'm like, why? What are you stopping? Anyway, which might be a discussion for another time, or you can explain yourself more, Dot Morton. I certainly see a lot of people at Microsoft who seal classes, even if they're internal. And I don't understand it, but that's fine. It's harmless. But as far as extensibility goes, it is better to seal and then unseal than the other direction, because that would be a breaking change. So we were talking about how to make this easier. This is tedious, right? Mutating a tree by copying it yourself. I mean, it's tedious because you have to repeat yourself, and we only have 2 properties, so it's not too bad. But imagine there were 15 properties on this thing. Or imagine, let's add one more field. What should we call this one? Height. We talked about height. Height in inches, okay? Now, once again, we don't want to make a breaking change, so we're going to clone this. Once again, we're getting more and more wordy here. Height. This height in inches. Okay, great. Except we have a problem now, because this code, which might not be in the same method, just dropped height. Now, we didn't actually use height, but suppose we did. Let's say, hey, we want, so we'll start with 0 fruit because we really want us to be 15 inches tall. We just lost it. So fruit height in inches. Let's come down here, put it here too. Tree prime. Let's take a look at our test output, and you can probably see where this is going. The fruit went up, but the height went to 0. So bad API for immutable objects if your pattern for creating and mutating them tends to break down anytime you change it. So I'll take a quick break. Dot Morton says, even if it's internal, I prefer keeping the API locked down. It's still an API, albeit for it. That's true. That's true. Okay, so how do we solve this? With copy on write mutating methods. So let's add a few methods here. And we're still in the tedious portion. So if this starts to seem like, wow, this is a lot more work than if we just made a mutable type, you're right, and we'll fix that. This is going to return a new tree, and we're going to call it with fruit count. And this method's job is to return a new tree that's just like this one, except instead of its own fruit count, we're going to return another fruit count, and then all the other properties are the same. So here we're going to replace this now with tree with fruit count. There. Let's see how our test did now. Look at that. Our height was preserved. And this code didn't have to know about height. So we can add more and more properties to this class, and this code will continue to run properly. That's good, but it's on now. What we've done is now moved some of the tedium from this side to this side. It's still tedious because, well, first of all, we don't have all the methods we need, right? We need with height in inches, return new tree, this type, this fruit count, this height in inches. Oh, let's see. We're not supposed to do that one. So it's kind of error prone as well, especially if you're copying and pasting code. You might not fill in the right thing, but we do have this now. And then finally we would do with type. So I am going to copy this. Type value, this fruit count. There. Okay, so we've got our with methods. Great. That is going to get more and more painful as the number of properties go up. Not only do our methods go up, but it becomes, I'm not sure whether it would be exponentially bad. It might be exponentially bad. If I add another one, let's call it root length. Can you imagine what I have to do now? I have to create another constructor or modify an existing one if I dare. I have to not only create another with method, but I have to change every single with method to propagate the root length. Otherwise, if I don't touch them, I have a subtle bug where some properties get dropped with some with methods because I forgot to change them all. So this it's becoming increasingly painful. We don't have any validation either, for what that's worth. Well, we have this, which is repeated in every single constructor, which is not fun. Now I could fix that somewhat. I could say this, right? And then this one could say, just chain my constructors. So now I validate just once. But what if I had overall validation to perform on this type? What if, maybe root length can never exceed the height? Where am I going to put that? Even if I put it here, where I have, in fact, wait a second. Yeah. Even if I have height, I don't have root length anywhere yet, so I'm just going to stick it on here. Root length. Then now I could do some validation, right? I could say if height is less than root length, throw new argument exception. Now, anybody see the problem with that? Well, besides the fact that I made a breaking change here somewhere. Oh yeah, see, I broke all of my constructors. Let's see, what do I need to do? Root length. Okay. Well, that was tedious and buggy because oh, there we go. See, another one. Root length 10. So that's legal because the root length is less than the height. Well, root length has to be more than the height. So how did we get by that test? How come it's passing? Oh, if it's larger. Yeah, okay. So we are okay. If I make this 20, it's going to fail, right? As it should. Yeah, there we go. So I'm going to do this, and then because I'm sneaky and I know the bug, I'm going to work around it by saying, okay, well now the height is just 5. Now that wasn't allowed up here. If I put height up here, oh, actually, I forgot I'm using the same constructor chain, so it is actually validating. Well, good for that. So there's but you can imagine with all of this redundancy and everything being expressed in multiple places, sometimes you can, in more complex scenarios, you might have some issues with that. finally, let's talk about one other angle before we move on to how we can improve on this dramatically. This is, it feels rather unnatural, right? I mean, you all of these getter properties, but to write, you have no property writers. Okay, so Martin says, is the with X naming convention .NET naming common .NET naming feels object C-ish. I'm going to say yes. It's pretty common. I know of a few APIs in .NET that are fairly popular that do use this. It's kind of fluent, if you want to think of it that way. Roslyn has a very deep, enormous immutable object graph. Every syntax tree, their semantic model as well, is all immutable. But it's copy on write. So if you've got a syntax tree, you can say, like a syntax node, say a method, you can say with body or with it. So yes, there's that. Also, let's see, I guess the immutable collections don't use the with syntax because they don't need it. But yeah, I don't know of any other prefix. I don't know of any other prefix as well as used as frequently as with. So when you're changing a property, that's what I tend to see. So it's a good pattern. Also, there are a few C# language proposals for making immutable record types that have a lot of things like with methods on it. So I think the with prefixes, if the C# language ever delivers on some of these immutable record ideas, we'll likely use with as the official prefix for some of that as well. So let's see. What I wanted to do, I wanted to talk about let's create an immutable collection and just study this as an example for a second. Let's create an immutable list of trees. Okay, so you see we have this builder, and I can actually create, I can say immutable list create. I can create an immutable list of tree right now and pass in the tree or trees, right? But then I have to, I can use the fluent syntax of this. I can say new, my first tree, and I can pass in my tree prime, and that's fine. Oops. But if I wanted to use this, okay, so it's, what? Oh, I forgot. I wasn't in the constructor anymore. So there's that. I wonder if I can add range. Union? No. I'm treating this like another type. So let me just do this. So I've created my immutable list with two things. But then if I have to remember that I can't just say add one more tree and have that work. I have to actually assign the result to something that every time I change it, I have to reassign the result. Also, I can't, if I had a method, and you've never seen a method that actually takes an iList before, right? I mean, goodness, this is so common. Add item. Let's say add new tree. iList of tree. Trees. So this will take a list of trees and add a new tree. Let's call it a pear tree. Okay? I can't pass that. I can't call this. That doesn't work. At least it'll throw. Watch. See? Boom. You can't add to an immutable list through through an iList interface because it's not going to mutate the existing object, which is what everybody expected. So it's super convenient that given a list, you can say to builder, or you can create a builder. So now we have a mutable list. Now, this doesn't make the original list mutable. It's a new object that can represent multiple values. And then once I've passed that mutable list to my helper method, I can go back and say mutable list, go back to immutable. And it creates, and this is very, very efficient. Internally, it's reusing as many objects as it possibly can. So there are allocations when you're doing immutable object mutate, copy on writes. You are going to allocate, but it minimizes them. But this was super cool. Like I'm going to be setting. I have a tree, right? Let's say grow tree. And what this wants to do is say with height, tree height, it's going to grow up by an inch. Well, great. Now I still have to return the tree. And while that's immutable programming and it's fluent and like there's good parts to that, and actually that might be your default. It may also be that you want to change a whole bunch of stuff. Let's say with fruit count, also add a fruit. Let's add 3 fruit. Okay. So we could do this, but what have we done? We've actually allocated 2 new trees for what is logically 1 mutation. So that's fine in a lot of cases, but in perf critical paths, you want to keep your mutations down. Also, remember we have validation here, right? Height can't root length can't exceed height. Well, what if I'm changing both? Now, I'd never actually created my root length method here. Maybe I should. But imagine I need to grow the root length and the height, and I do it in the wrong order. See where this is going? The height, if I grow the root length before the height, even though in the end it's going to be a valid state, if an intermediate state is invalid, it's going to throw. Not cool. Okay? So what I'd really like to do in cases like this is either postpone validation to the end, or what if I could do this? What if I could change them both with 1 mutation? I just said width, and I could say height in inches is tree height plus 1, and then I could say fruit count, tree fruit count plus 1. Okay, so now we've only allocated once, and the validation only happens once. So I don't have to worry about ordering of could I possibly have mutated into an intermediate or an invalid intermediate state. Except, how do you implement this? And it is not as easy as it might strike you at first. There's one other thing. Well, this is still somewhat inconvenient. I mean, it's not bad. It's a lot better. But what I'd really like to do in some cases is just mutate the thing. I'd like to say plus plus. Wouldn't that be nice? And without the intermediate mutations. I'd just like to do that. Why isn't there a tree builder? That's what I'm getting at. Well, I could create a tree builder class and give it all mutable properties, and then write the code like the immutable collections have of converting an immutable tree to a tree builder and then back again. We already have something of a maintenance nightmare where every single change that I make has to change a constructor at least once, all of the width properties, and now I'm saying I've got to change a whole nother class as well, and all of the copy constructors and all that. Like, oh my gosh, this gets worse and worse. And I've done this. We have some substantial code in Visual Studio itself for the common project system that does this. We have a couple of large types that are immutable, and we never did make the builder because it's hard enough to maintain just the immutable version of it. At least I don't think we have a builder. The width method, though, just to illustrate the problem space, let's go back here and comment out this so we actually have something that might compile. I'll show you what a width method might do. Now we just have a width method that's going to take everything. It's going to take type, it's going to take fruit count, it's going to take height in inches, root length, and it's going to return a new tree with all those values. But wait a second. If you're thinking this looks like, what value did that width method add? First of all, it didn't make this work because I didn't pass in enough arguments. And second of all, they could have just as easily called the constructor. So we haven't actually done anything useful here. Okay, so let's do this. I don't have. But why not? Why don't I do that? Let me do that real quick because this is an awesome feature. If you haven't used it, nullable. Is it nullable enable? I think that's what it's called. Now I can come over here and even make nullable ref types. No? Maybe I need to set the compiler version too. Lang version 8. Now is that happy? Yes, it is. Great. So I'm going to say, look, all of these things can be null. And what I'm going to say is use the type given, the value given, and then I'll make all of them optional, right? Okay, look at that. Look at that. We fixed the compiler error here, so that's good. And if you don't supply the type, it's going to inherit the old one. I'll do one line per property is probably really good practice when you're dealing with arbitrarily large objects. Okay, we got something now. That's good. What is it complaining about here? Type is never assigned to. Tree type? Oh, I think that's old. I don't think that's, yeah, that's, okay, now it's gone. So we've got something. It's more convenient. It's one allocation. Mutation is only going to happen at the end. We have one glaring hole. Bonus points for anybody who can guess what it is. In this case, type isn't supposed to be null anyway, so there's no valid reason for someone to pass in null here. But let's say that there was. Okay. What we need to do is create a situation where there's ambiguity between an omitted argument and an argument that is set to the default value. Okay, so let's say that trees can optionally have names. And I just killed my live unit testing again. So there's an optional name, and for I don't know if I want to add a constructor. I'm too lazy, right? I'm already having that problem. Let's add this. You can only set the name by using the with method. So name, null, we're following the pattern here. Oh, actually, I do have to have a constructor, duh. Name or the existing name. So let's go up here and go ahead and add the name. All right. Still looking at the chat window to see if anybody can call out the mistake or the issue that's going to come up. All right, first of all, I have to update all these. Oops. Come on, get back there. There we go. Name. And of course, I have another breaking change here. Name. I'll go ahead and call it. We'll call it favorite. So there we are. Live unit testing died again. All right. So what I want to do is, so tree was called favorite. If I go up here and say name, but tree prime isn't my favorite anymore. I've got a new favorite. So I'm going to say with name, not favorite. Well, I'll just, but that's kind of lame to say it's not my favorite. I'll just set the name to null. So tree prime. So let's see what got printed. The test runs again. All right. Wait, still says favorite. Why? This is the problem. When we called with name null, see, we could have called, it would have worked if I'd said not favorite. That works. See, there it is, not favorite. So why didn't null work? Because when name is null, it automatically faults in the old name. And why did it do that? So that other uses of with don't have to specify name. So this is the situation where you do need to know, is name null because it was omitted from the caller, or because they explicitly passed null in? This is a solvable problem, but it adds a nullable struct wrapper. Like suddenly your signatures become more complicated on the right side. On the left side, it's nice and easy. But I'm not even going to bother coding that up manually. Instead, we're going to replace all of this mess with a much, much simpler way. So let's install the NuGet package that I wrote that automates so much of this. And at the moment, actually, and I'll be curious whether y'all see value in this, because I haven't actually invested in this for a while. So it's still a pre-release package. You have to actually check include pre-release to see this. So I'm going to install the immutable object graph generation, because we're actually going to be generating immutable objects. And this is a README file that tells you exactly how to get started. So let's go back over here to your tree class. We're going to add one using here. And then we're going to decorate this tree, and we're going to make it a partial class. Then we're actually going to delete everything. It's going to be wonderful. Boom. Get rid of all these methods. And the properties we're going to change to fields. They're now just read-only fields. And we want them to follow camel case because properties will be generated for us. So there we go. That's our new tree, and it has everything fixed. Take a look at this. It's all hidden, but look over here in the members list. Hopefully you can tell. We've got the dark, or rather the bright fields listed here. Those are the ones in this current file. But there's all of these gray members. So here's the constructor. I'm going to go ahead and make this bigger. It generated the constructor for us that takes each field, and then it initializes the fields for us. I'm wondering what this problem is. Oh, yeah, I do need to get rid of this nullable type, though, because I haven't updated the immutable object graph to deal with nullable ref types. Okay, so here is initializing the fields. I talked about validation, so there's a place for you to put validation on it. Here are the property getters that it generated for us. And we'll talk about some of these other things too. There is a public constructor, but there's also a static factory method for create. And we'll talk about that. But here's the with method that kind of led into this. Notice this optional of T wrapper. This is what gives the ability for the method to tell, was type omitted or was it just null? So we'll come back to that in a minute. Identity is, because it turns out when you're dealing with immutable objects, these values, it can be useful to recognize one tree from another, even if it's value equal. You have two apple trees, but they're not the same one. So identity, basically each of these immutable objects also is assigned a unique integer, so that it can recognize this tree is the same as another one. And when these trees copy on write, they take their identity with them. And that's important because, again, like I said, if you have two apple trees, they're not the same identity. Well, it depends. Did one tree evolve from another? Are the two objects just a representation of the same logical tree, but at two different states? Or are they two distinct trees? Turns out that's a very important concept. And so when you create a new tree, it gives it a new identity. But when you mutate an existing tree with copy on write, it preserves the original identity. So you can see the identity, well, with core, we'll do it. Actually, if we go to here, here it is, identity. So it passes the identity along when it does the copy on write. So we'll come back to the right side in a minute and explain some more. But now take a look at this. So we've got new tree. Now it uses Pascal case for the properties there. I don't remember why I did that, but also it's recommending we don't use the constructor. It's for deserializers only. Oh, that's why I make them Pascal case. They have to match the properties so that deserializers can find it and know what constructor to invoke. But the constructor isn't there for you. In fact, we hide it from completion lists. No, debugger browser. I think I meant to do editor browse. Oh, these are fields. Anyway, so I don't hide the constructor from completion lists apparently. But what it wants me to do is this: create. And now all of these fields are optional. So I don't have to specify 0 anymore. I can say its height in inches is 15, and its root length is 10, and its name is favorite. So that's more convenient right away. And then, let's see, I have, instead of having, no, it actually goes both ways. I'll show you how this works. But for now, we're saying instead of having one with method for every single property, which just makes it for a really, really long set of members, and it makes it harder, I would argue, for your users. It just has one with method, and you can say, okay, with fruit count, and that's it. You're done. And I said also with name null. So this works. I can say two different with methods, or I can combine them. I could say with fruit count of 1 and name null. Okay. So that's awesome. Again, it doesn't like me using the constructor here. So what I would do, especially since I'd say tree create. Boom. So this is a unique tree. It's not a mutation. Let's do one more thing. Since we were talking about identities and we want to be able to discern between new and evolved trees, let's actually print out the identity. So there's the identity of tree, and here's the identity of tree prime. Yeah, I guess I'll just run the test manually since live unit testing keeps breaking. So here we go. Apple tree, 0, fruit, 15, height, favorite, identity is 1. And then when we grew it up, we have 1 fruit instead of 0. And the identity is still 1. And the name is null. That's awesome. It could tell that we specified null. If we don't specify it at all, let's run it again, just to show, that means that the name will actually propagate because it's optional if T knows, hey, it wasn't specified, therefore they weren't trying to clear it. So there's favorite. So I said there were options. There's lots of options. Let's say you did like the with fruit count method. So you can say define with methods per property true. Now check it out. You've got with root length, with name. So you can say with name. There you go. And because it's an explicit method for each property, it doesn't have to use the optional T syntax. You see, that's just a string that it's taking. So you can do that. So let's drill in and see how this works. And we'll use these helper methods because it's slightly easier to work with. So actually, well, you can see. So first of all, the with methods are smart enough to avoid allocations when it's not necessary. If you say, hey, I want a tree like this one, except I want it to be 20 inches. Well, if the original one is 20 inches, it just returns this. And you can prove that that should be equivalent to the code that's calling because it's immutable. It doesn't matter if it gets one copy or another. But assuming it is different, it is going to call with, and it's going to pass in height in inches, just like you could have over here. And it has to do some special stuff, optional for I don't remember why, maybe overload resolution, but you don't have to write this. This is strictly inside the generated code. But if we jump to with, we see with calls with core, and we'll get into why that's important. And it just passes in everything that possibly could have been passed in. And then with core calls with factory and basically forwards it on. And again, if this seems like, well, that's a lot of indirection, why does he do that? I'll show you. And finally, this is where the actual magic happens of look. If first of all, it checks to make sure it's actually different. If the type was, or the identity was given, or let's go to type. If type was actually specified and it's different, or something. So it's basically making sure, look, something's going to change when we create this new object, right? Otherwise, just return this. And then it says, okay, pass in whatever identity we were given or our own identity if no value was given. So that's where all that happens. Now, why do we have all that indirection? Because remember, this is so simple. This is like the simplest class you could imagine. What if we had a special kind of tree? Let's go ahead and get rid of this for simplicity's sake now. Generate immutable partial class. Let's say apple trees are rather special and they have thorns. Horrible example, but apple trees have thorns. No other tree does. This is where the generated code does stuff that would just make you want to, cut yourself if you were doing it by hand. Okay, so now we have an apple tree. Now you could say apple tree create. Oh, you know what we forgot? We forgot the derived type. Tree. Did you notice though? It only took thorns, right? But when we say that apple tree derives from tree, look at that. The constructor knew that there are lots of fields from the base, and it's this method was inherited from the base class. So it's a static method, right? When you can call static methods on derived types. So this one doesn't have thorns. This is just the standard tree method. We actually want the apple tree create method. So we're going to say type apple, of course. We're going to say thorns 5. Now, when we call with, again, there are 2 methods because we inherited something from the base class, right? Tree with doesn't have thorns. So when we say type, we're going to call this just plain apple instead of apple, of course. All right, so this is apple prime. Now here's the trick, though. This with method isn't defined on apple tree. It is defined on, overload resolution decided to call that one, even though I didn't specify thorns. Let's kind of force the issue for a second. Some tree equals apple tree, because this is polymorphic, right? So this code doesn't know that it's dealing with an apple tree. It's just dealing with some tree. So some tree prime. Now we're definitely calling the with on the base method. Here we go. See? I said go to definition on this. It took me to this with method, which is on tree. What am I going to get back? I don't want a tree. I want an apple tree. This method is supposed to return me the original object copied with one change applied. But with is defined on the base class. So how is it not going to create a new tree for me? Let's add an assertion here. Assert is type. I still expect it to be an apple tree, some tree prime. Let's run the test and see if it passes. There it did. Why? Because this with method on the base class calls with core, which is virtual, and with factory is a private method. So what we overrode with core in apple tree. There it is. But there was a little bit more to it. You see that we have 2 with core overloads. That's because the base class's with core overload doesn't take a thorns. But we need a with core that takes thorns for the derived class. So you actually need 2 with core methods. One's an override, and one is a virtual method so that apple tree itself can have a derived type. So it all works out. Let's see, what else to show? So we can create templates. Let's say you want every tree. Have you ever seen a partial method before? It's uncommon, but there are partial methods. It gives you a template, and you can say, look, every new tree has a height of 1. Okay, so now I specified height here. I did not specify height on my apple tree, but I can say assert equal 1 apple tree height in inches. Let's try live unit testing again. And it's basically, since you don't own the constructor in immutable object graphs, yeah, that didn't run. You can't put defaults in the constructor, and putting them as field initializers doesn't work either in every case. So we give you this partial method that you can optionally implement to set the default. And it's making me a liar because I set it on tree instead of apple tree. So let's move this. Apple tree has its own default. There we go. I can also do validation. Partial validate. Except this one I want to put on tree. And I want to say if this root length exceeds this height, then throw new argument exception, or whatever I want to, whatever exception makes sense in this context. And then this validate is run not only every time, from the constructor like it was before, but check this out. Remember how we talked about builders? Oh yeah, we can do builders now. Builder, generate builder true. And we'll do it on both. Turns out with this little code generation thing, it's really important in a given object in a type hierarchy like tree and apple tree. You got to pick the same properties for both, or else it can't handle it. So now we're generating builders. So check this out. Now I could say tree to builder, tree builder, and now I can do it this other way. And then I can return to immutable. Now, if you've seen the immutable object graph or immutable collections, this idea of to builder and back to immutable should seem familiar. But it works because we didn't just create tree. We created a tree builder. And look, the properties are not only mutable, but we actually go ahead and implement iNotify property changed for you, just in case you want that. And there's no validation that occurs. When you're mutating a builder, you can do it in any order. But when you say to immutable again, it will do a copy on write on the original immutable it was based on. And that, if you follow it all the way through, is where validation happens. So you don't have to worry about growing the root structure before you grow the height. It's just going to work. So Brad Wilson asks, can't you just inherit the attribute from the base, or are you trying to preserve the idea of having a mutable object driver? That's a good question. Actually, you know what? That's a pretty good idea. Internally, the way this whole thing works, I mean, obviously I'm generating code, and I have to do that before the compiler runs. But I'm also using the compiler to help me with this. What's happening when you add that package reference, it's adding a build step just before compilation, and I do it in such a way that it integrates very well with Visual Studio as well. So that all you have to do is save the file or switch, I think maybe an unsaved file switching context also does it. I don't remember for sure. But if you just save the source file, Visual Studio will trigger the same MS-build target. And what that target does is it will, in an MS-build task, it loads the project, has the C# compiler parse it, and then it looks for these attributes, and then it will start applying patterns and start generating code in this extra file, which you don't tend to check into source control. It's in the OBJ directory, as all generated code should be. So we're using Roslyn to find this attribute, and then we apply the patterns to every single class. But having this attribute say that it inherits, and then asking Roslyn for the semantic attributes instead of the syntax attributes, sounds like it ought to work. That's actually a really good idea, Brad. Again, I wrote most of this years ago, so I don't remember if I've tried that and then there was something that prevented it from working, but that's worth a shot. That would help keep this consistent, so you just don't even define this. You don't have to worry about duplicating it everywhere. So there's one other thing. So define it. Oh, let's say you wanted an I tree as well, right? You can do that. Or rather, you can let the machine do that. So here we are. Here's your I tree. Immutable, of course. It's a beautiful thing. Let's see. It's internal, by the way, because it inherits the accessibility from this type. So if we say public on both of these, then theoretically I believe that interface will become public. There it is. Yep. So you can do this for internal types, public types. Now I wanted to show you one more thing. File system, and I'm going to just jump over to another solution that I prepared. This one represents file systems. And this becomes interesting because of the recursive nature of this object graph. A tree, we had a derived type, but there was no collections in any of these things. So imagine you had a file system entry. This can represent a file or a directory. So every file system, whether it's a directory or a file, it has a name. But only files have size. And only directories can store other file system entries. So this is a fairly easy thing to model, as long as it's mutable. As an immutable object graph, this is horrible for all sorts of reasons. Because imagine if you've got this enormous immutable data structure and you want to add a file 5 directories deep in the structure, what you have to do is what I call a spine rewrite. So you take the directory 5 levels down. You have to mutate a property, so it's a copy on write property. The property is an immutable collection. You have to add a new file, create a new file, add it to an immutable collection, update the property on an immutable on the file, the directory. So you have to replace that directory with a new one. Then you have to replace its parent with a new one, and then its parent with a new one. And in immutable collections, we do spine rewrites all the time because internally it's an AVL tree. And so when you add an element, it has to rewrite every node that until it gets to the root node. But that's all internal. It can be done by a library. But when you are defining the types and the data structures, a library can't do it. It has to be code you have, which is why you have to have a code generator to make this sane. So what this can do is you can add a file 5 levels deep, and it does the spine rewrite for you. So if we come over here, because this is all fluenty, immutable objects, you can say, look, I want to create a directory. Its name is // I'm going to give it config sys and autoexec bat, which is a nod to the old DOS days. It's got a Windows directory as well, where kernel 32 DLL is present. Okay, so that's cool. You've got. I'm you're seeing some extra types because I haven't shown you these 2 things. So let's actually delete these for a second. Better. So now if I had, let's keep Windows around for a second. Let's see, directory, win. So now I want to add a file to the Windows directory, right? So I can say file create, I don't know, PowerShell.exe. That didn't do anything because this is an immutable object and I'm returning an immutable object. And this doesn't do anything either because really what I need is root to update. So what I would need to do is say root replace, that makes it look too easy. Let's see, with entries, root entries, replace the old win with this one. And this is the new root. Well, that was only 1 level deep in the directory structure, so that wasn't totally insane. But you get the idea. I have to create the file, add it to this directory, then replace the old directory for Windows with the new directory for Windows in what turns out to be the root. This is a lot, and you can't imagine like writing this code when it's arbitrary levels deep. So the immutable code basically when you have obvious recursion, the code generator can tell, wait a second, you're storing a collection of types in your own type hierarchy. It generates some helper methods for you. So now you can just say, look, add descendant. I want to add this. And which parent? Windows. And that's it. No, arbitrary deep, arbitrary levels of deep. Wherever win shows up in that recursive tree, it will do the spine rewrite for you. And because that spine rewrite changes the objects, right? Win is no longer current, right? So like win is changed. Like my win is the same. I took a snapshot of win. This win still only has 1 file, kernel 32. It doesn't have PowerShell. But root has a new win that has PowerShell. So what if I wanted to add 2 files? What if I wanted to add PowerShell 2? Does this work? It's not the right win. It's not going to match. But remember that identity property I was telling you about? How sometimes we want to actually be able to tell, is this the same thing as what we had before? It does work. Because really it's looking for any object in the recursive tree that has the same identity. It doesn't have to be the same instance, which makes this incredibly powerful. And then besides add descendant, you can say replace descendant. So let's say kernel 32 file k. So I'm storing kernel 32, and later I want to say, look, I want to replace k. Look, it just updated node again because of that identity. I can fix up k right now. I can say with name and use capital K in this kernel 32 DLL, and it knows, even though you're only giving it the new k, it knows the identity, so it finds the old k and removes it and replaces it with this one. Hans91 says, want to become famous? Buy followers primes. Let's see. This looks like an ad. So no, thanks, Hans. I'll let word of mouth make me famous if that happens. One last thing, because I'm out of time. Let's bring back deltas, and let's bring back define rooted struct. Oops. This was kind of tedious. I had to keep reassigning my local. But if I say root, let's just call it rooted. Root with root. Rooted is a struct, so there's no allocation involved in that. But now I can just do all of those, or many of the same operations. I can add entries, and I don't have to reassign it constantly to a new local because the struct keeps track of that. Also, I can, so let's call this root prime. Okay, I can say root prime changes since. What has changed since root? And I can actually list it, and that's what I've done here. Root prime. So let's run this. This will efficiently walk through the recursive tree object graph, and it will actually tell me all the changes that have been applied. So given an immutable object, because that's the problem, right? When you have a mutable object in your graph, you can have an observable collection, iObservable collection, or iNotify property change. Like you can actually know when to update UI. You can respond to changes. But if you have an immutable object graph, and you're going to store that in some mutable field somewhere, sometime, well, all you know is that the reference changed. You have no idea what changed within that object graph. So you don't know what UI to update, what events to raise. So changes since solves that problem for you too. So if I walk through this, let's go to locals here. One change that it identified is the name change. Remember how we changed the kernel 32 DLL? Look, it gives you the old and the new. It shows you that before it's a lowercase k and after it's an uppercase k, and it's telling you that a node was replaced in the tree and that the name changed. Let's keep going because we made more changes than that, right? Let's loop around. Next change, it's saying kind added. So a node was added to the tree, and so before it was null, after it was PowerShell exe. It's saying that this file was added, which is exactly true. We did this. So it gives you a very efficient way, even though you're dealing with potentially very large immutable object graphs, to track what changed across time between any two versions of object graphs, which is awesome. I didn't really show you too much about the defined root struct, but we're out of time for today. So I hope you found this useful. If you did, let me actually show you the link to where you can go get this and more information. If you go to ImmutableObjectGraph on my GitHub account, here's basically what we went over. I'd love to hear whether you felt this is useful. File an issue, vote it up, or let me know how it goes. I feel like this is super, super powerful for a lot of applications. I'd love to hear more from you. So Dot Morton says, so all this code generation cleverness seems to run off class attributes. Could I do it off non-code files instead? Say I have some YAML files in my project. Can I get it to generate code and update as the YAML updates? You could. And with some effort, the immutable object graph could be made to be adaptable to take its inputs from multiple places, including YAML files. And if you did take it from YAML files, you wouldn't have to worry about, like, there's certain rules you need to follow. Like you should put read only in front of each of these fields. That's because while we can generate new code, we can't modify the existing code. So if you want it to be immutable, you've got to do that yourself. But if you did it in a YAML file, you could generate all the code and have fewer problems. So that's certainly an option. What happens is this class is analyzed, turned into an object model of its own for the code generator, and then it generates a bunch of code. So if your object model came from YAML instead of C# code, that should work. In fact, Roslyn, I mentioned Roslyn has an normal immutable object graph. It does it similarly. It is code generated, but it's using XML. At least last I heard, they were using XML as their input for their code generator. The code generators are not the same. They wrote theirs just for them. I wrote this for every project, basically. So I'd love to believe that they could replace their XML code generator with this, but I don't know. Okay, so Dot Morton says he wants to know more. So I will put a link to this in the chat, so you can go check that out. I actually also have a blog, dev blogs, Premier Developer. If you search for immutable object graph, I don't know why this blog is so slow. It's always slow. There we go. This is another introduction to this idea, so I'll put that in the chat as well. So you can follow that and let me know what you think. So next week we'll probably cover async threading, async and multi-threading deep dive, or whatever is the most popular voted topic on my Twitch channel for next time.